Good afternoon, all of you. So today I will give some numerical problems on EMF equation of the transformer. So a 500 kVA, 11,000 by 400 volts a single phase transformer has 100 turns on secondary winding. Calculate the approximate number of turns in the primary winding, approximate value of the primary and secondary currents, and the maximum value of the flux in the core. So we all know that transformer having around 98 to 99% efficiency, 98 to 99% efficiency, because transformer is a static device. There is no rotating parts in transformer. So 1% is the losses existing in the transformer. If you neglect the losses, 1% loss in transformer, so input equal to output when we neglect the 1% losses. So input power of the transformer is given by V1 I1 cos theta 1, V1 I1 cos theta 1. So this is the cos theta 1. So this is equal to V2 I2 cos theta 2. Single phase transformer input power and output power. So this is the AC power cos theta 2. V1 I1 cos theta 1, V2 I2 cos theta 2. So cos theta 2 is because of impedance drops. So impedance of the primary winding is R plus jx1, impedance of the primary winding. Impedance of the secondary winding is R2 plus jx2, R2 plus jx2. Because every winding having some resistance and reactances in AC circuits. So this is the impedance of the primary winding Z1, impedance of the secondary winding Z2. So Z1 and Z2. So this is because of winding resistance, winding reactance, primary, secondary resistance, secondary reactance. So if two impedances are approximately equal, you assume that if two impedances are approximately equal, Z1 equal to Z2, so cos theta 1 equal to cos theta 2, cos theta 1 equal to. So therefore, V1 I1 equal to V2 I2. Here we made two assumptions. One is the small amount of loss, V1 I1 equal to V2 I2. Small losses is neglected, two impedances are equal. So we made two assumptions in this case. So that's V1 I1 equal to V2 I2. So therefore, V1 by V2 equal to I2 by I1. From this equation, V1 by I1 equal to V2 by I2. So similarly, in a transformer, primary ampere turns equal to secondary ampere turns in this manner. So this is the primary ampere turns, primary current, secondary turns, secondary current, primary ampere turns AT equal to secondary ampere turns. So from these relations, so this is the relation of the, we derive this relation. So transformer is a 500 kVA transformer. So 500 K means to 10 power 3, that is 1000. V1 I1, that is approximately equal to V2 I2, this is equal to 500 kVA. This is the capacity of the transformer, power rating. 500 into this value. Okay. So similarly, this is a V1 by V2 equal to N1 by N2. So from this N1 equal to V1 by V2 into N2. So from this we calculate the primary turns N1. Primary turns N1. So from this relation we calculate the current. So V1 I1, that is equal to V2 I2, that is equal to power rating of the transformer. So from this we calculate primary current and secondary current. So 45.54 is the primary current. 1250 amperes is the secondary current. So primary voltage is value 1000. The secondary voltage is the V2 by V1. Given values are V2 by V1. V2 by V1. So this is in the given voltage rating is the V2 by V1 value. So 11,000 is the V2 value. 400 is the V1 value. V1 by V2. So from this we calculate I1 and I2. So this is the EMF equation of the transformer. So from this EMF equation, E equal to 4.44 flux, so frequency, number of turns, volts. So this is the voltage value. So from this we calculate the flux, maximum value of flux, phi m value. So the phi m value equal to, we know the time voltage. So this is the given value of voltage. So this is equal to V1 4.44, frequency 50 Hz. So number of turns on primary is 2750 value. This value. You substitute all parameters in this equation, we get flux. Yes, flux value. So this is the second problem. So 67600 volts by 230 volts. 50 Hz single phase core type transformer has core section. Core section means cross section area. So in this manner, this is the core cross section. Core cross section 25 into 25. 25 into 25 centimeters. Calculate approximate number of primary and secondary turns if the fluctuations in the core is not exceed 1.1 Webers per meter square. So this is our flux density B max value. Flux density B max. So the total area of the cross section of the core is calculated. Cross section quantity is given in centimeters. Cross section is given in centimeters, that is converted into meters. So 25 into 10 power minus 3 or 25 by 100. 25 by 100 meter square area. So this equals 6.25 into 10 power minus 2. So phi m equal to Bm into E. Flux density equal to flux by area. So flux equal to Bm into E. So Bm given value 1.1. Area 6.25 into 10 power minus 3. So this is the phi maximum value. So here we calculate the approximate number of primary and secondary turns. We need to calculate N1 and N2. We know that EMF equation equal to 4.44 maximum value of flux phi n. So from this, N1 is calculated as N1 means E1. So here E1. Substitute N1. So here E1. N2 E2 value. From that we calculate the N1 value. Similarly, N2 value is also calculated. So E1 equal to 4.44 flux frequency number of turns. E2 equal to 4.44 flux frequency number of turns in secondary. So given voltages are V1 by V2. In nameplate rating, if voltages are given, that is the V1 by V2 values. These values. So here this is the V1 value by V2 value. Similarly, in last case also. In this problem also, this is the V1 by V2 values. V1 by V2 values.
అంటే నేను దగ్గర చెప్పాను నేను మళ్ళీ కనెక్ట్ చేస్తాను ఆయనకి సార్ గారికి కస్టమర్కి కలమని సార్.
So this is the third problem. First, single phase 50 Hz transformer has 100 turns on primary winding and 400 turns on secondary winding. It has two windings, primary winding and secondary winding. So 100 turns on primary, this means the primary having 100 turns, secondary having 400 turns. So the secondary winding having 400 turns. 400 tons. The net cross section area of the core is 250 centimeters square. Area is given in centimeters. Area is given in centimeters square. The primary winding is connected to 230 volts 58 supply. Determine the EMF induced in the secondary winding. So primary voltage is given, voltage V1 value 230 volts, supply frequency 50 Hz is given. Determine the EMF induced in the secondary winding. E2 value is need to calculate it, and maximum value of flux test in the core. Maximum value of flux test in the core. So any transformer V1 by V2 equal to N1 by N2, that is equal to I2 by I1. Same equation is written in current. So this is approximately equal to I2 by I1. I2 by I1. V1 by V2 equal to N1 by N2, that is equal to I2 by I1. So first we need to calculate EMF induced in the secondary. This is the V2 value. V2 value. So the V2 is approximately equal to E2. Insert no load E2 equal to V2. So V2 equal to V1 into N2 by N1. That is equal to E2 equal to V1 N2 by N1. V1 value is given 230 input supply voltage 230. N2 value number of turns on secondary. N1 is given. N2 is given. From that we calculate induced EMF in the secondary winding. E2 value. So EMF induced in the secondary winding is 920 volts calculated. So we know that EMF equation of secondary winding E2 equal to 4.44 maximum value of flux frequency number of turns on secondary volts. Also this is the volts in terms of volts. So then from this we calculate the flux value. So this is the flux. This is calculated maximum value of flux. So flux density equal to flux by area. Bm equal to 5m by E. A is given in centimeters square. You have to cross 25 centimeters square. So 250 centimeters square area of the cross section. So 250 centimeters square converted into meters square into 10 power minus 4. So this is the maximum value of flux density. Different kVA transformer has voltage ratios. Voltage ratios means V1. So the ratio is given in terms of V1 by V2. V1 by V2. Calculate the primary and secondary currents. So transformer rating is equal to primary volt amperes and secondary volt amperes. So this 25 kVA. So this 25 kVA probably is voltage into current. K means 10 power 3. V means voltage. A means current. So kVA rating of the transformer is given is equal to this value. So this is also equal to V2 I2 V2 I2 by 1000. V2 I2 by 1000. Same value. So if you want to calculate I1 equal to 1000 into kVA rating of the transformer. kVA rating of the transformer by V1 value. So volt amperes rating, voltage into current, volt amperes means voltage into current, kVA by kVA means by 1000, kVA rating of the transformer. Okay, you want power rating in kVA, volt amperes rating by 1000. Okay, so from this I1 equal to kVA rating is given in 25 kVA. So 1000 into kVA rating is 25 by voltage, primary voltage. So V1 value, so 300. 7.5 amperes is the primary current. 7.5 amperes is the primary current. So similarly, secondary current, 1000 kVA rating is same, 25 kVA by V2 value. Is equal to 62.5. So primary current is 7.5 amperes. Secondary current is 62.5 amperes. See, primary voltage is more, current is less. Secondary voltage is low, current is high. So that is the purpose of the transformer. If current value is voltage value is decreases, current value is increases. circuit. See, so this is a transformer having primary coil and secondary coil, having two coils. So this is the core of the transformer, secondary coil, primary coil. So primary voltage 3300, 3300 volts. Secondary voltage 400 volts. So that means this is a step down transformer. This is a step down transformer. Transformer rating is 25 kV. This transformer rating is common for both windings. So primary power rating that is equal to secondary power rating in the transformer. Primary power rating equal to secondary power rating in the transformer. So kVA rating also given 25 kVA. Suppose V1 I1, the transformer V1 I1 equal to 25 kVA. So this is equal to 25 kVA. 25 k means 10 power 3, 10 power 3, 10 power 3 volt amperes. Volt amperes. PA volt amperes. So if you want I1 value, so I1 equal to 25 into 10 power 3 by V1 value. V1 equal to 3300. V1 equal to 3300. Same formula. So I1 equal to 25 into 10 power 3 by 3300. Similarly, current on secondary circuit. V2, I2 equal to same power. The transformer primary and secondary coils having same rating. Voltage into current rating. Voltage into current equal to same values in transformer. So similarly, you want secondary currents. Secondary current V2 I2 equal to 25 into 10 power 3. 25 into 10 power 3. So I2 equal to 25 into 10 power 3 by V2 value. V2 value equal to 400 volts. V2 value equal to 400. So this is the value. Okay. So primary voltage is high. Primary voltage is high. So 3300. Secondary voltage is 400 volts. So this is the I1 value. So this is the I2 value. Primary current, secondary current, I2. So primary current equal to 7.5. This is the primary current value. Secondary current value 62.2. This value. Secondary current value this value 62.5. See, voltage on primary side is 3300 volts. So current is very small, 7.5 amperes. Secondary voltage 400 volts. Current value is very high, 62.5. In this manner, voltage to current, current to voltage transformation occurs in the transformer. Change it. Voltage value decrease, current values increase. Voltage value increase, current values decrease. So in this manner. This is the second problem. A 125 kVA. kVA rating of the transformer is 125 kVA rating of the transformer. Having primary voltage of 2000 volts. Having primary voltage of 2000 volts at 50 Hz has 182 primary and 40 secondary turns. 182 primary, so that means M1 equal to 182. Secondary 40. Neglecting the losses. If you neglect the loss in transformer, primary voltage is equal to secondary voltage. Or primary ampere turns equal to secondary ampere turns. Primary kVA equal to secondary kVA. Neglecting the losses, calculate the full load primary and secondary current. So primary current is secondary current at full load. So no load secondary induced EMF. So E2 value and maximum flux in the core. Maximum flux in the core. 5M value. Maximum flux in the core. So full load primary and secondary current, that is I1 value, I1 value, I1 value, I2, I1, I2, and 5 maximum. Okay, these three parameters need to be calculated. So if you neglect the losses in the transformer, if you neglect the losses is neglected means primary volt amperes Means primary voltage into current equal to secondary voltage plus secondary voltage into current. Neglect the loss in a transformer. Okay. So if you want to calculate the primary current, you want to calculate the primary I1 equal to, so power rating 125 into 10 power 3 by primary voltage. Primary voltage is 2000 volts. So this comes I1 equal to 62.5 amperes. Now in the transformer, in another formula in transformers, primary ampere turns. Ampere means current. Turns means number of turns. N or T. So in this textbook, number of turns is represented with T. In this column, number of turns is represented with T. And the T1 primary turns, T2 secondary turns. So I1 N1 equal to I2 N2. So this I1 N1 equal to I2 N2 N2. Okay. So if the turns is represented with the Tn. So I2 equal to I1 T1 by T2. I1 value is 62.5. T1 value is also given. Primary turns 182. Primary turns 182. Primary having 180 turns. So primary turns. By secondary turns 40 turns. So this is secondary turns. So therefore secondary current equal to 280 amperes. Secondary current. So from the same equation, number of turns. Transformer V1 by V2 or E1 by E2. So E1 by E2. The transformer E1 by E2 equal to N1 by N2 or T1 by T2. Here T number of turns is represented with T. T1 by T2. So therefore E2 T1 equal to E1 T2. Same, this is same formula. Number of turns is represented with turns. Therefore E2 equal to E1 T2 by T1. E1 T2 by T1. So there is a secondary intensity EMF. Calculate the flux, the maximum value of flux. So maximum value of flux equal to induced EMF in the primary, that is 2000 volts on primary voltage by 4.44 frequency primary turns. So this is the flux value, maximum flux value. In this manner, we calculate the currents and the voltages in a transformer. Okay, and I see. So this is the transformer primary winding, the core of the transformer, secondary winding of the transformer. So this is step-up transformer because the primary having N1 turns, secondary having more than N1 turns, that is N2. So more turns means this is step-up transformer. Step-up transformer. So this is the primary supply voltage of the transformer. Alternating, we apply primary voltage, alternating voltage, that is represented with V1. So this is the primary current of the transformer, I1. EMF induced in the primary circuit is represented with E1. EMF induced in the secondary is represented with E2. So when load is connected on secondary side, so this is the load, electrical load is connected on secondary side of the transformer. Electrical load. So this is the load L. Here the voltage across the load is represented with V2. So this is represented with V2. Secondary current I2. Secondary current I2. So in a transformer, So transformer is a static device. So losses is very low in transformer. So losses is very low means efficiency is very high. So at full load transformer have 98% or 99% in some cases is there. 99% efficiency is there in transformer at the full load condition. So that means 1% power is wasted in the form of losses. Losses means core losses plus copper losses, that is 1%. So if we neglect the 1% losses in transformer, so there is around approximately input power equal to output power. If you neglect the losses, input power equal to output power in a transformer. Input power equal to output power in a transformer if you neglect the losses. So input power equal to output power means input power is given by V1 AC power, input AC power V1 I1 cos theta 1. So this is the single phase input to single phase input. So theta 1 V1 I1 cos theta 1 input per phase active power. This is active power. So this is equal to V2 I2 voltage into current. In DC circuits, power means voltage into current. But in AC circuits, power means voltage, current, and phase angle difference between the voltage and current. That is the cosine of cos theta 1. Cosine of phase angle difference between the voltage and the current. So on cos theta 2 and cos theta 2. So if you neglect the losses in transformer, input power equal to output power. That is V1 equal to V1 I1 cos theta 1 equal to V2 I2 cos theta 2. So V1 I1 cos theta 1 equal to V2 I2 cos theta. So generally every winding, every coil, so this is the winding, this winding is made with copper. Copper having some resistance, small value of resistance. So that resistance winding resistance is represented with in series with the winding. Okay. So that means if we neglect the losses in transformer, if we neglect the losses, so that means we neglect the resistance of the copper winding. So that means resistance is neglected, loss is neglected, copper loss is neglected. Similarly, the reactance is also neglected. Reactance value also. Therefore, primary cos theta 1 equal to secondary cos 1. Both having same power factors. Same power factor. Cos theta 1 equal to cos theta. So therefore, in a transformer, if you neglect the losses, V1 I1 equal to V2 I2. V1 I1 equal to V2 I2. Therefore, in a transformer, we neglect the losses and resistance and reactance V1 I1 equal to V2 I2. So from this V2 by V1, V2 by V1 equal to I1 by I2 equal to I1 by I2. So this is a very important relation in transformers. V2 by V1 equal to V2 by V1 equal to I1 by I2. Remember this equation. This equation is also represented with the K. K means transformation ratio. This is represented with the K. So the K is called transformation ratio. Transformation ratio. Voltage to current, current to voltage. So transformation ratio is defined as secondary voltage by primary voltage or primary current by secondary current. So this is called transformation ratio of the transformer. So voltage ratio means V1 by V2. Transformation ratio means V2 by V2. Voltage ratio means given value V1 by V2, that is called voltage ratio of the transformer. Transformation ratio K means V2 by V1 in transformer. V2 by V1. Okay. So this is very, very important that you must be neglected in the transformer. And that must be remembered in the transformers. Next, next. So in a transformer, principle of the transformer is Faraday's laws of electromagnetic motion. So the MMF of the transformer, MMF means N into I. MMF means N into I. In a transformer, primary MMF equal to secondary MMF. MMF means N into I. Primary MMF means N1 I1, that is equal to N2 I2. Magnetomotive force. MMF means N into I. So that is called MMF. So MMF equal to N into I. MMF means N into I. Number of turns on primary and number of turns primary current N1 I1, that is equal to N2 I2. So in a transformer, so I1 is the primary current, I1 is the primary current, N1 is the primary, so I1 N1 equal to I2 N2. I1 N1 equal to I2 N2. So MF means magnetomotive force. Magnetomotive force is given by N into I. In any, this is in magnetic side. EMF means electromotive force. EMF means electromotive force. So electromotive force equal to V equal to EMF equal to IR, current into resistance or impedance. EMF equal to V equal to IR. P, voltage equal to current into resistance. In DC circuit, so current into resistance. In AC circuit, V into Z, I into Z. V equal to IZ in AC circuit. In DC circuit, V equal to IR. So this is the MMF in magnetic circuits, EMF in electrical circuits. So in a transformer, primary MMF equal to secondary MMF. Magnetomotive force. So N1 I1 equal to N2 I2. So from this relation, N1 by N2, N1 by N2, from this relation N1 by N2 equal to I2 by I1. I2 by I1. See the reverse relation. I2 by I1. So N1 by N2 equal to I2 by I1. So from these relations, voltage current relations also, we derive the final relation transformers. So that is the transformation ratio of the transformer is given by transformation ratio means voltage, secondary voltage by secondary primary voltage. So transformation ratio in a transformer K is given by K equal to V2 by V1. So that is equal to I1 by I2. So this derived in last slide, I2 by I1. So this is equal to N2 by N1. N2 by N1. N2 by N1. So this is the transformation ratio of the transformer. Transformation ratio of the transformer K equal to V2 by V1, that is equal to I1 by I2. I1 by I2, that is equal to N2 by. So depending upon this relation, the problems are solved. See the relation. How the relation is the system is in this relation. Okay. See the voltage and current relations. Whenever K equal to V2 V1. So it is equal to I1 by I2. That is equal to N2 by N1. So this reverse V1 by V2 means N1 by N2. V1 by V2 means N1 by N2. So let's see the relation. So V1 I1 equal to V2 I2. Okay. So this must be remembered in every problem. This must be remembered. So V2 by V1 equal to this value. V2 by V1 equal to N2 by N1. Same relation. V2 by V1 equal to N2 by N1. So if you neglect the impedance drop, so V2 equal to E2. If you neglect the impedance drop, so V2 equal to E2. Neglect the impedance drop. So depending upon this formula, I1 and 1 equal to I2 and 2. So instead of number of turns n, we replace with the number of turns t. N is replaced with the t. Just simple. N is replaced with the t. And our next class I will explain about the transformer, phasor diagrams of the transformer on tomorrow's class.